Hello all, myself Kalpana, Triple Department Mlritm, working as an assistant professor. Today I am going to explain about the electromagnetic field theory subject. As part of this, previously I have explained module 1, that is electrostatics. Today I am starting the module 2. The topic name is Conductors and Dielectrics. So first of all, what is the behavior of conductor in electric field? So in first module we have discussed about what is electrostatic field. Okay, now we'll discuss about how the conductor will behave in a electric field. So here, for that I am taking one conductor here like this. Okay, so here we have in a conductor we have free electrons, so which will be moving. When we apply the electric field, external electric field, they will move in a opposite direction of the electric field. So these free electrons, these are the free electrons. In the conductor, we have free electrons. So these free electrons will move in a conductor in opposite direction to the applied electric field. So negative charge will occur when flux, as already know, electric flux will flow in a conductor in a random manner, that is in perpendicular to the direction of electric field. So here negative charge will occur in a flux lines enter, and positive charge will occur when the flux lines will move. Means this is a negative charge when flux enters like this, and it is flux lines are leaving here. So here we have a positive charge. So and the charge density inside the conductor is 0. The charge is accumulated on the surface of the conductor, and the flux lines on the surface are perpendicular to the conductor surface. This is a surface, and these flux lines are perpendicular to this surface. Okay. So when a conductor is placed in an electric field, the electric field intensity inside a conductor body is 0, because internal field is equal and opposite to the external field. So it will be nullified. So charges are distributed outside the conductor surface, and electric flux lines leave or enter at 90 degrees, that is perpendicular to the surface. In conductors, electrons move freely under the influence of electric field. The potential on the surface and inside the conductor is same, and hence the conductor surface is an equipotential region. So as we know that this is the del V, that is potential, equal to del V equal to minus E, so equal to 0 throughout the body of the conductor. So no charge is enclosed inside the conductor body, since all charges are on the surface only. That is, charge resides on the surface, not inside. Okay. So this is whenever conductor is placed in a electric field. So now we'll discuss about what is current and current density. So as we know that current is defined as rate of flow of charge, and it is measured in amperes. So here the current is considered to be motion of the positive charges. The conventional current is due to the flow of electrons which are negatively charged. Hence, the direction of conventional current is assumed to be opposite to the direction of flow of currents. Okay, so next we'll define the drift current. The current which exists in the conductors due to the drifting of electrons under the influence of applied voltage is called the drift current. Means whenever we apply the external electric field like this, so we have a conductor here, we have free charges. Here we are applying the external electric field. Okay, so here when we apply the electric field, these charges will move. Means this is due to the drifting of electrons under the influence of applied voltage. So that current is, because of that these charges are moving. So that current is nothing but a drift current. Next one is convection current. So this convection current is due to the dielectric material. So whenever in dielectrics, there can be flow of charges under the influence of electric field intensity. that current is nothing but a displacement current or convection current. So for this example is when a current flowing across the capacitor. Capacitor is a dielectric material like this. So it is separated with a distance d. So here we are keeping a dielectric here. So this is the example for convection current. Next, current density. So it is defined as the current passing through the unit surface area. Means whenever we are considering it is a conductor, okay, it is having charges like this. So here the density of this current means here current is moving like this. So this is in particular area. So that is nothing but a current per unit area. Current passing through the unit surface area is known as current density. So it is measured in amperes per square meter. That is current density. We are defining it as J. J equal to current per area. So current is amperes and area is in meter square. So unit of this current density is ampere per square meter. So here the current density is a vector quantity. So it is having direction. Okay, so it is denoted as J. So next, so we can define this current density like this here. Whenever under the effect of applied electric field, available free electrons means here we have a conductor like this. Okay, so here we are applying a electric field, external electric field, and here we have positive and negative charges are present. Okay, so whenever we apply a external voltage, these charges are moving opposite to this. Means positive charges will go to the negative and these negative charges will go to here. So that there is a striking of these. Whenever these electrons are moving, this will strike the adjacent atoms and rebound. Rebound means so they form like this inside the conductor. Okay, so in random direction, there is no direction here. So this is called drifting of the electrons. I mean drifting means some push. Okay, so after some time these electrons attain constant average velocity. Means after rebounding of these electrons and these positive and negative ions, they will rebound with some constant velocity. This velocity is called the drift velocity. So the current constituted due to the drifting of such electrons is in metallic conductor is called a drift current. So means these are moving after they will get the velocity. So this drift velocity is directly proportional to the applied electric field. So that is nothing but Vn is proportional to E. This constant proportionality is called the mobility of the electrons. Mobility means some movement of this electron. So this is denoted by mu E. It is positive for the electrons. So Vn equal to minus mu E into E. Here this negative sign indicates the velocity of the electrons is against the direction of electric field. This is opposite to the direction of electric field. So here this mobility equal to some velocity by electric field. So from this equation, okay, so the unit is square meters per whole second. According to the relation between, as we know that J and V are related as J equal to rho V into V, that is current density is nothing but some rho V into V. So, but in the material, the number of protons and electrons is same. So, and it is always electrically neutral. So here, positive and negative. Positive and negative, that is number of protons equal to number of electrons means that will be nullified. That is, these are cancel out each other. This is electrically neutral. So, for that, rho V equal to 0. So, drift velocity is the velocity of free electrons. Hence, this equation will becomes J equal to rho E into Vn. So, here Rho E is nothing but charge density due to free electrons. The charge density is obtained from the product of number of electrons per meter cube and charge on one direction. So rho E equal to N into E, number of electrons into E. So here N is the number of free electrons per meter cube. Then after substituting rho E value, we'll get J equal to minus rho E mu E into E. So J is a current density. So next point form of Ohm's law. From this relation between this current density and electric field intensity, so we can write for metallic conductor J, current density J equal to sigma into E, where sigma is conductivity of the material. So the unit of this is Siemens per meter. So conductivity is measured in Mohs per meter. Here this J equal to sigma is nothing but a point form of Ohm's law. So when we compare this equation with the previous equation, that is J equal to minus rho E into mu E into E, we'll get sigma equal to rho E into mu E. So this is the conductivity in terms of mobility of charge density of the electrons. So J equal to sigma into E is nothing but a point form of Ohm's law. So next we'll see the properties of conductor. So here first property, under static conditions, no charge and no electric field can exist at any point within a conducting material. Okay. Next, the charge can exist only surface of the conductor, which gives rise to surface charge density, that is rho S. And within the conductor, the charge density is always zero. Only the charge will be accumulated on the surface of the conductor only, not inside the conductor. So the charge distribution on the surface depends on the shape of the surface. Okay. And the conductivity of an ideal conductor is infinite, means it is having high conductivity. And the conductor surface is always equipotential surface. So these are the properties of conductor. So next, dielectric material. So it is seen that there is conductors have large number of free electrons, while in insulators and dielectric materials they do not have any free charges. The charges in dielectrics are bound by finite forces, and these are called bound charges. Bound means we have positive charge, negative charge like this. So these are bounded. So as these are bound, it is not free, they cannot contribute to any conduction. Whenever we apply electric field, they shift their relative positions against the normal molecular or atomic forces. Because of forces, this will shift their relative positions. The shift in relative positions of bound charges allows dielectric to store energy. Whenever these are moving, they will store some energy. The shift in positive and negative charges are opposite directions under the influence of applied electric field. Such charges act as a small electric dipoles. Dipole is nothing but we have positive and negative. So this is called a dipole. So when dipole results from the displacement of bound charges, the dielectric is said to be polarized. Okay, so polarized is nothing but whenever this dipole results from the displacement of bound charges. So this is moving like this, again another one moving like this. So this will constitute the charge of bound charge. So this is nothing but polarization. Okay, so and these electric dipoles produce an electric field which opposes the externally applied electric field. This process, due to which separation of bound charges results in producing electric dipoles under the influence of external electric field, is called polarization. Okay, so for that I am considering a dielectric which consists of nuclear, so this is positive charge, and with positive and negative charges are in the form of revolving electrons in the orbits. So means these are moving like this. The negative charge is considered to be in the form of cloud of electrons. So this is a cloud of electrons. Okay, so which is shown here. So when applied field is 0, that is electric field is 0, the number of positive charges is same as negative charges. Hence, atom is electrically neutral. Means how many positive are there? There are number of positive charges equal to negative charges. Then it is that atom is electrically neutral atom. Due to the symmetry, both positive and negative charges are assumed to be point charges of equal amount, coinciding at the center. Center is nothing but here, positively charged nucleus. Hence, there cannot exist any electric dipole. So, this is called an unpolarized atom. Okay, this is the unpolarized atom. When electric field is applied, the symmetrical distribution of charges gets disturbed. Okay, so the positive charges experience F equal to EQ. So this is from Coulomb's law. While negative charges experience a negative force, that is in opposite direction, F equal to minus Q into E. Now there is a separation between nucleus and center of electron cloud. This atom is called polarized atom. See, this is the polarized atom and this is the equivalent dipole. The equivalent dipole is formed like this. The dipole gets aligned with the applied electric field. So this process is called polarization of dielectric material. So for polarization, there is a mathematical expression. So from that dipole is formed due to polarization, there existed the electric dipole moment P, that is given by P equal to Q into D. Q is a magnitude of two charges and D is the distance between the negative to positive charge. So let N is the number of dipoles per unit volume and delta V is the total volume of the dielectric and capital N is the total dipoles. Then that is equal to number of dipoles into total volume of the dielectric, that is N into delta V. Then the total dipole moment is obtained by using the superposition principle, that is P total equal to Q1 D1 plus Q2 D2 up to Qn into Dn. So this is the total dipole moment. So next, coming to the properties of dielectric material. As already discussed, the dielectrics do not contain any free charges, but they contain bound charges. The bound charges under internal molecular or atomic forces cannot contribute to conduction. Why? Because these are placed in a atom, that is in dielectric material. The distance between these are very large. When subjected to an electric field, the bound charges shift their relative positions. Due to this, small electric dipoles get induced inside the dielectric, that is called a polarization. Due to polarization, the dielectrics can store energy and the flux density of the electric increases by amount equal to the polarization. The induced dipoles, whenever this here polarization is formed, there is induced dipoles produce their own electric field aligned in the direction of applied electric field. So when polarization occurs, the volume charge density is formed inside the dielectric, while surface charge density over the surface of the dielectric. The electric field outside and inside the dielectric gets modified due to induced electric dipoles. So these are the properties of dielectric materials. So I have taken these from the U.A. Bakshi, that is Electromagnetic Theory by U.A. Bakshi and also William Hague. Thank you.